Hi students, today we're going to do 11.3 notes. Acceleration. Acceleration is the rate of change in velocity, both speed and direction. There are 4 ways you can accelerate. You can speed up, slow down, change direction, or change speed and direction. A lot of times you don't realize that, but changing direction, because acceleration does have speed and direction, is an acceleration, whereas you normally don't use that when in common day language. Acceleration values, you can either have a positive or negative acceleration. When an object speeds up, it is positive acceleration, and negative acceleration is when an object slows down. Constant acceleration. Constant acceleration is a steady change in velocity. So the velocity changes by the same amount each second. Then there's instantaneous acceleration. That's a change in velocity at a given instant. So at that moment, what the change in velocity was. Calculating acceleration. This equation will be given to you on the test. A is equal to Vf minus Vi over delta t. A is your acceleration in meters per second squared. Your Vf is your final velocity in meters per second. Vi is your initial velocity in meters per second, and the change in time is just your the delta. This symbol is just a delta symbol, and that means change in. So the change in time in seconds. So that equation will be given to you on the test, but you need to know how to rearrange it, and the only one you need to know how to rearrange it for is the VF. So you could try and pause and try to rearrange it, and we will do that together on the next slide. So I rewrote the equation, which you might want to do in order to rearrange it. The first thing you want to do is get rid of the delta t. So you want to, since it's dividing, you want to multiply by delta t on both sides. That cancels this out. So we've got delta t times A is equal to Vf minus Vi. Then we want to get rid of the Vi, so you would add Vi on both sides. So that gets rid of the Vi. So your Vf is equal to A delta t plus, now I'm going to make this t a little bit different so we know the difference between the t and the plus Vi. So you should put that equation in your notes because that one won't be given on the test, and you should know that. So we're going to do a couple of problems. Find the acceleration of an object that went from 30 meters per second to 12 meters per second in 8 seconds. So this meters per second was a velocity, this is a velocity, and 8 seconds is a time. And we are looking for acceleration. So first you always write down the equation. So A equals Vf minus Vi over your t. And if you forget to write the delta sign, that's fine as well. So the biggest problem kids have is figuring out what the Vf and the Vi is. If it goes from 30 meters per second to 12 meters per second, that means you're ending at 12. So this is your final, and this is your initial. So we're going to have the Vf was your 12 meters per second, and you're going to subtract the 30 meters per second over 8 seconds. So 12 minus 30 is a negative 18 meters per second, and divide that by 8 seconds, and negative 18 divided by 8 is a negative 2.25, and the unit will be meters per second squared, because the seconds don't cancel out, they just get doubled up on the bottom. So it'll be meters per second squared. The reason why it's negative is because you decreased in speed, so you had a negative acceleration. Our next example problem is an object at rest accelerated at 4 meters per second squared in 6 seconds. What is the final velocity? So it says we have 4 meters per second squared. That was an acceleration. Here is our 6 seconds is our time, and we're looking for final velocity. So we're going to use the other equation. So we're going to be looking for our final velocity, and that is equal to your AT plus your VI. So our A is our 4 meters per second squared times our time, which was 6 seconds. And now we don't have a VI, but it is in there, just might not see it. So if it says an object at rest, if it's at rest, that means it started at 0. So that means it started at 0 meters per second. So that's our VI. And so 4 times 6 is equal to 24, and the seconds cancels out. And so we're left with 24 meters per second. For this slide, you only need to copy down this up here that I just kind of squared off. Do not worry about this figure down over here or the equation down here at the bottom, because you already have that equation. So free fall is the movement of an object toward Earth solely because of gravity. And we'll talk more about that next chapter. But the acceleration of gravity is 9.8 meters per second squared. So if you use the equation that we just talked about, which is down here, you can figure out the velocity at different seconds. Because at 0 seconds, if a ball was falling to the Earth, at 0 seconds, it starts at 0 meters per second. At 1 second, it accelerated by 9.8, so now the velocity would be 9.8 meters per second. At 2 seconds, it would be 19.6. And all you're essentially doing is plugging in the different times to this equation and then multiplying it by 9.8. So 2 times 9.8 is 19.6. At 3 seconds, it would be 29.4 meters per second. That is it for today's notes.